In this session of SpaceClaim course, we're going to talk about Enclosure Tool. In CFD modeling, an enclosure is a simple volume you create around your part to represent the surrounding flow thermal domain. In SpaceClaim, the Enclosure tool quickly generates that wrapper, a box or cylinder, at specified clearances around your solid. You then treat the enclosure as fluid, air, water, etc., and the original part as solid. The enclosure's outer faces become your domain boundaries, inlet, outlet, far field, and its inner face coincides with the part's surface for heat and momentum exchange. To explain this command, first I import the geometry of an aircraft that was previously drafted into the software. Now I intend to create an enclosure around this UAV. Before doing so, I first align my geometry with the origin of my design environment. To do this, it is enough to use the Move command and shift my geometry to the desired point. Now, to perform the operation, I go to the Prepare tab and select the Enclosure option. Now, according to the software instructions, I first select the bodies for which an enclosure is to be created. As you can see in this section, there are several different options available for creating an enclosure, including box, cylindrical, spherical, and custom shape types. I start with the box format. As you can see here, we have the default cushion option, which specifies the automatic clearance of the enclosure from each side of the geometry. By default, this value is set to 25% of the geometry's largest length, and it can be decreased or increased. The Symmetric Dimension option allows us to define the distance from each side of the geometry symmetrically. For example, when we change the enclosure distance from the front side of the geometry, the software automatically applies the same distance to the back side as well. However, when it is disabled, the enclosure distance from each side is set independently. Share topology makes touching bodies in SpaceClaim literally share the same faces, so the mesh is conformal across that contact. If you enable it when creating an enclosure, the solid's outer surface and the enclosure's inner surface become one common face. In Fluent, this yields a single coupled wall where fluid and solid meshes match node to node, giving clean heat and momentum transfer without extra setup. If you don't enable it, the solid and enclosure keep separate faces. Meshes won't match, and Fluent treats them as two walls that you usually couple via a non-conformal interface. Here, I create a spherical enclosure. Sometimes, when there is no heat transfer between the solid and the fluid, we don't need to keep the solid body. By subtracting the solid from the fluid domain, we can analyze momentum, pressure, and, for example, shear stress effects. As you can see, after removing the solid body from the geometry, its volume has been correctly and automatically subtracted from the enclosure. Next, I also create another enclosure in the box format. This can be useful when we want the mesh to be finer near the geometry, allowing us to mesh the spherical enclosure with smaller elements. Now I proceed to name the different parts of my domain, such as the inlet, outlet, and symmetry. Now, by hiding the outer surfaces of the spherical enclosure, I name the surfaces that will act as the aircraft walls. Note that these surfaces are not the surface of the solid body. I hope this video was useful for you. To benefit from Mr. CFD's services, including simulation, consultation, and training, visit our website and contact us via these addresses.